All right, so a little review from last class. We got a bouncy ball or whatever. Okay, it's dropped from 175 up to 135. So we have to find the rebound ratio first. So we get our rebound height divided by our starting height. So 135 divided by 175. Usually when we do this, okay, we'll have you round to 3 decimal places. So in this case, we'll just call it 771. You can always put it in as a fraction as well. So when we want to find out how high it bounces on the 7th bounce, we can say our starting height is 175. We could just plug this straight in so we don't have to worry about rounding if we want. Okay, and then raise it to the 7th bounce. So plug it into a calculator, 175 divided by our rebound ratio, raised to the 7th power. Okay, we get, and again, we can round it to 3 spots here, 28.452. Okay, if you use just the 3 decimals, it's going to be a little off. All right, we get 28.341 or something, so it's pretty close. Okay, but obviously just being able to set it up, I wouldn't care that much if you got one of those two. That would be good enough for me. So today we're gonna kind of reference back to this, okay, in talking about sequences. What is a sequence? All right, you guys probably woke up this morning and you were like, man, I hope Anderson tells us what a sequence is. That'd be great. I'd really get my day going. Okay, so a sequence is essentially a list of numbers that follow a specific pattern. So we really have we have 3 options. We're mostly going to be dealing with 2 of them. Okay, the first one is what we call arithmetic. That is when you are adding between each term. Okay, and the formula for that, we'll talk about in a little bit, okay, is T of n equals dn plus c. The other sequence is geometric. This is when you are multiplying between each term. And the equation for a geometric sequence is T of n equals a sub 0 times r raised to the nth power. Again, we'll talk about that more in a bit. Okay, the third type would be neither, where you're not adding or multiplying between each term. Okay, but it's following a different pattern. Right? And there's no formula for that because the pattern could be a whole bunch of different things, so there's no real pattern. Okay, so here's an example. Okay, we have the numbers 8, 10, 12, 14. Okay, then there's 3 dots at the end, which insinuates that this pattern continues going on forever. So it's a list of numbers that continues, okay, forever and ever. Okay, so two things you have to, or a couple things you have to ask yourself. One, are we adding or multiplying between each term? So we're asking, is it arithmetic or geometric? Okay, in this case, we are adding each time. So this one's going to be arithmetic. So now we have to ask ourselves, what are we adding each time? And this is referred to as our generator. Okay, we could be adding or multiplying. It's still going to be the same term. So it's called the generator. Yeah, how do we get from one term to the next? In this case, we are adding 2. Okay, so then the last part would be we have to find the 0th term, and this can get a little tricky. Okay, but it's important to note that 8 is our first term, so we have to think about what would come before 8. Okay, so if we're adding 2 going this way, we'd have to subtract 2 to go back 1. Okay, making our 0th term 6 in this case. So for an arithmetic sequence, we use this equation, T of n equals dn plus c. Okay, where d is our generator and c is our 0th term. Okay, so to make an equation, we would just say T of n equals 2n plus 6. Okay, so the good thing about arithmetic equations is they are pretty much the exact same thing as the slope of a line, right? Where we had y equals mx plus b. Okay, this is our slope, right? What are we adding each time? We're adding 2. Okay, this is our y-intercept or our starting point, 0th term. Okay, 6. All right, let's take a look at a geometric equation now, or geometric sequence. Okay, so again, first thing you ask yourself, are you adding or multiplying between each term? In this case, we should be able to identify that we are multiplying. Okay, so we have geometric. Second thing you ask yourself is, what is your generator? What are you adding or multiplying by each time? In this case, that should be 2. And then the third thing, what is your 0th term? Okay, so again, 10's your first term. If we're multiplying by 2 going to the right, we have to think about what would come before 10. So opposite of multiplying by 2 would be dividing by 2. So our 0th term would be 10 divided by 2, or 5. So the equation for a geometric sequence would be T of n equals a sub 0 times r raised to the nth power, where a sub 0 would be your 0th term, r would be your generator. What are you multiplying by each time? So we get 5 times 2 to the n. Okay, which is the same equation we use to find our rebound heights, right? Our starting height. What are we multiplying by each time? Raised to whatever bounce. Okay, it's the same equation, same setup. Okay, this time we're just being given numbers instead of asked to find rebound ratios. Okay, so let's say we had, let's see, I'll just take that F1. Let's say we had 9, 7, 5, 3, dot. Okay, we identified it as arithmetic. We know we're subtracting 2 each time as our generator. Our 0th term was 11. So we have T of n equals negative 2n plus 11. So let's say you were asked, okay, given the sequence, what is the 20th term? Okay. So really what they're asking is, what is t of 20? And all you're going to do is you're just going to plug 20 in for n and solve. So we get negative 40 plus 11, which means t of 20 is equal to negative 29. Okay. Could you have just taken that pattern and just written out 20 numbers? Sure. Okay. If I asked you what's the 1000th term, okay, that would probably take a while. Much easier just to be able to plug in an equation. Okay. The other one, let's say we had and again, we identify it as geometric. Our generator is 1/2. Our 0th term was 96. So if we wanted to find the 10th term, t of 10, and obviously we would need a calculator of sorts. Okay. We'd get an answer of 3/32, or the decimal, 0.093775. Okay. So again, that's kind of why it's important to identify it as 1/2 as our generator as opposed to dividing by 2. Okay. If you plugged in 2 as your generator and you tried doing that, okay, we'd get 98,304. Okay. And if just kind of using common sense, we're trying to think about what would be the 10th number. For it to be a really big number doesn't make any sense, because it is decreasing in value. Okay, so it's important again that we identify that it is what are we multiplying by each time, not what we are dividing by. Okay, so given these two sequences, okay, identify the equation and then come up with first one t of 7, second one t of 20. This first one, identifying if it's arithmetic or geometric. Hopefully we can see we're multiplying by 2 each time. That makes it geometric. So we need our generator, which we just said, we're multiplying by 2 each time. And then our 0 term, what would come before 5? Well, if we're multiplying by 2 going that way, we have to divide by 2 going this way. So it's 5 divided by 2. Okay, a lot of people wrote 2.5, which is fine. So now with our equation, we need our 0 term first, which is 5/2. Our generator is 7 raised to the nth power. So to find the 7th term, okay, we plug it into this equation here. Okay, so now again, similar to the rebound ratio, okay, how we type this into a calculator is a big deal. So I'm trying to make mine work. Okay, if I have a graphing calculator or something fancy, it's pretty easy. Okay, I'll show you on my phone here though. I'm sure some people like to use that. Okay, if I try and just say 2.5 times 2 raised to the 7th, I did it right anyways. Okay, trying to get at is you want to make sure you raise it to the 7th power first and then multiply it by 5/2 or 2.5 to get the right answer. Okay, so a couple of people saying 5/2 times 2 first. Okay, order of operations, remember exponents come first. Okay, but t at 7 should be equal to 320. Okay, one thing you can keep in mind too, if I'm asking the 7th term, is that far out? Not really, right? Plus you're already given the first 3 terms. So we could say 5, 10, 20. I'm just going to keep this pattern going. 40, 80, 160, and 320. There's my 7th term, 320. Okay. So if you're given a smaller number, you can always check your work. Like if you're asked the 7th term, if I asked you the 70th term, I wouldn't recommend writing out 70 terms. You're just going to have to kind of trust yourself. Same thing on the second one. The 20th term, I don't know, it's kind of a lot of work. Okay? But you could at least check your work here. Make sure you did it right. 320 should be the 7th term. Okay, second one here. 15, 20, 25. We're adding 5 each time. So it should be arithmetic. My generator is 5. My 0 term, what would come before 15, should be 10. Since it's arithmetic, I have to use Vn plus C. So I get T of n equals 5n plus 10. Finding the 20th term, I plug in 20 for n. And I get 100 plus 10, which would be 110.